The steps in creating custom subnet masks. Step 4. Determining the host IDs. There are essentially 4 steps to custom subnetting. The first step is to design the physical network. Now, in many cases, the physical network may be already designed for us, and what we need to do is determine, first, the number of physical segments on the network. Then second, we have to figure out the maximum number of hosts on each physical segment. Now, step 2 is to choose a subnet mask, actually a custom subnet mask, that creates a number of subnet IDs that is greater than or equal to the number of physical segments, and also the subnet mask, the custom subnet mask, must give us a number of host IDs on each physical segment that is greater than or equal to the actual number of hosts on each physical segment, because we always have to match the software, that is the numbering of the IP addresses, to the physical segments. Then, step 3, we have to determine and number our subnet IDs, because they will be used when we sit down and number the actual host addresses. To properly address our IP networks, we'll need to create a separate subnet or range of IP addresses for each physical segment. Now, we will specify these different subnets or range of IP addresses with a subnet ID. Now, I'm starting with a Class B address, the 152.77.00. Now, the default subnet mask, of course, because it's Class B, is 255.255.00. The 255 is indicating the portion of the IP address that is the network ID, and the 0 is indicating the portion of the accompanying IP address that is the host ID. Now, according to this Class B network and the associated subnet mask, I have one network ID, and I could support 2 octets of hosts, which is about 65,000 hosts. But what I want to do is create subnet IDs to number my physical segments. So what I'm going to do is, in a sense, steal or take some of the bits normally reserved for host addresses and turn them into subnet IDs, or use them as part of my subnet mask. When using custom subnet mask, we set up our subnet IDs like this. Now, all hosts or device will share the same network ID. Now, in our example, our network ID is 152.77. Now, all physical segments, all hosts will start with that because that's assigned to our entire network. Now then, each physical segment of the network would have a unique subnet ID, and then all computers on that physical segment would share that same subnet ID. Now then, of course, each host would have to have a unique host address, and that's unique to the subnet ID. In the next few presentations, we'll be going through an example to demonstrate how to do custom subnetting. Now, in this example, we have a physical network, and that physical network has 5 physical segments, and those segments need to support a maximum of 5,000 hosts on each segment. We've had assigned to us a Class B address, 152.77.0.0. Now, that's our network address, and it's our job as administrators then to set up the IP addressing for our network. This is the chart we've developed. This is the subnet ID host chart for Class B network, and it specifies all the valid subnet masks we can use with a Class B network subnetting 1 octet, ranging from 1 bit to 8 bits, and it gives us the number of subnet IDs and the number of hosts per subnet ID. And then whenever confronted with a design problem, first we identify how many physical segments we have, how many hosts per physical segment, and then we look for a subnet mask, a custom subnet mask that gives us enough subnet IDs and gives us enough host IDs per subnet to match the physical network. So we've looked at all our possible choices for custom subnet masks, and we found one that works. Now, we found that the custom subnet mask of 255.255.224 works for our network. Now, the first 2 octets, remember, we're using a Class B, they're cast in stone, so it'll always be 255.255 and then some number, which is the custom subnet mask, in this case 224, because 224 gives us 6 possible subnet IDs, and we have 5 physical segments, so that works. And it also gives us over 8,000 host IDs per subnet, and since we only have 5,000 physical hosts per physical segment will have plenty of addresses. So the subnet mask 255.255.224.0 would be used on all devices on our network. And then it'd be our job as administrator to hand out the actual IP addresses and potentially default gateways. We've decided on a subnet mask of 255.255.224.0. Now remember, since this is a Class B address, the 255.255 is cast in stone, and we're setting up our custom subnet mask of 224. Now the custom subnet mask of 224 says that the first 3 bits of that octet are part of the subnet ID, and the last 5 bits are part of the host ID. Now let's take a look at the possible subnet IDs from a binary perspective. Now I've listed those out on the chart on the left. Now the first possible subnet ID, now again I have 3 bits, these are highlighted in red, dedicated to the subnet ID. The first one would be 000 in red. Now that's invalid, just like 111 will be invalid at the end, because we have to throw out the high and the low, unless of course all our devices support RFC 1812, and then we don't have to throw these out, but for the purposes of these courses we will throw out the first and the last. Now the first actual subnet ID we could use in binary would be 001. Second subnet ID in binary, again focusing in on the subnet ID, the red portion, would be 010, then to 011, and all the way down to 111, throwing out 111. When we convert these numbers to the decimal numbers, we have to convert the entire octet, not just the subnet ID portion of that octet. So when we take that third octet and we convert it, now in the case of the first subnet ID, we convert the octet 001, that's the subnet ID portion, but then we have to add the host ID portion, 5 additional zeros, to convert the entire octet to 32. So our first subnet ID would be 152.77.32.0. And then doing the decimal conversions right down the line, the next one is 152.77.64.0, 96.0, all the way to 224.0. In our example, we used a custom subnet mask of 255.255.224.0. Now that gave us 6 possible subnet IDs, and what we're going to do is use those to set up our numbering on our physical segments. So our first physical segment would have the subnet ID of 152.77.32.0. Next one, 152.77.64.0, 96.0, 128.0, and 160.0. Now remember, we did not use the first subnet ID, the 0 subnet ID, or the last one, which is 224. Now we could use those if all of our devices were RFC 1812 compliant, but in this case we're going to throw those out. Now we only used 5 of the possible 6 subnet IDs, so we would have another subnet ID, the 192 subnet, for expansion at later times. Now the reason we've created these subnet IDs is because these give us the boundaries or range of IP addresses that are assigned to the devices on each physical segment, and we'll need that in the next section when we start actually numbering the host IDs. Once we've determined our subnet IDs, we're ready for step number 4, which is to number our host IDs. And let's take a look at it from a binary perspective. Now again, our subnet mask is 255.255.240. Now our first subnet ID would be 152.77.32.0. Now the first host on that network would be 152.77.32.1. And if you take a look at the binary number, you can see that the binary number is 001, that's the subnet ID, and then all zeros with a 1 at the very end denoting the first host. Now we would keep incrementing in binary each additional host. So the next host would be 10, the one after that 11, 100, 101, and on and on and on, until we got to the very last host on the first subnet, which would be all ones with a 0. Now if we do the conversion from binary, we see that the last host is actually 152 152.77.63.254. So all the host addresses, the host IDs from 32.1 through 63.254 are on the same subnet ID. And the reason that is because if you look at the binary, every number from 32.1 through 63.254 starts with the first three digits, the first three bits the same, 0, 0, 1. And according to our subnet mask, only the first three bits are part of the subnet ID. The second subnet ID would be 152.77.64.0. The subnet ID in binary would be 0, 1, 0. Now the first host would be 152.77.64.1, and it would increment all the way up to the last host on that subnet, which would be 152.77.95.254. So again, all addresses from 64.1 to 95.254 are on the same subnet, and that is because every number from 64.1 to 95.254 starts with 0, 1, 0 in the first three bits. So all those addresses would be available to numbering hosts on the same physical segment. Now the third subnet ID would then start at, now the next subnet ID would be 152.77.96.0. The first host would be 152.77.96.1, and it would go up just to the next subnet ID, the fourth subnet ID, which would be 152.77.128.0. So the third subnet ID would end just before the fourth one started, so the last host on the third subnet ID would be 152.77.127.254, and the fourth subnet ID would start at 152.77.128.0. Probably the easiest way to number your hosts or determine your host IDs is to first determine the subnet IDs. And I've listed out our subnet IDs from our example here. For subnet ID would be 152.77.00. We're going to throw that out. And the first one we can actually use is 152.77.32.0. Now remember, if the first one starts at 32, each next subnet ID will increment a multiple of 32. Now once we set up our subnet IDs, the first host is always essentially a 1 added to the subnet ID. So if the first subnet ID is 32.0, the first host is 32.1. If the next subnet ID is 64.0, the first host is 64.1. 96.0, first host 96.1. Now the last host always ends just before the next subnet begins. Now our scenario here, the subnet ID 32.0, the first host is 32.1, and it ends at 63.254 just before the next subnet ID starts at 64.1, and then that subnet ID goes all the way up to 152.77.95.254, ending just before the next subnet starts at 96.1. Let's look at another example. Now in this case we're using a custom subnet mask of 255.255.252.0. According to our subnet mask and subnet ID table, the first subnet ID with a custom subnet mask of 252 would be 4. So our first subnet ID is 152.77.4.0. And if our first subnet ID starts at 4, then each successive subnet ID starts as a multiple of 4. So our next subnet IDs would be 8.0, 12.0, 16.0, and on and on. Now once we have our subnet IDs identified, it's very easy to specify the first host on each subnet, because if the subnet ID starts at 4.0, the first host is 4.1. If the next subnet ID starts at 8.1, the first host on that subnet would be 8.1. 12.0 is a subnet ID, first host is 12.1. Determining the address of the last host on each subnet is also straightforward, because the address of the last host is an address that ends just before the next subnet begins. Now, on the subnet 4.0, the first host is 4.1, and the last host is 7.254, which ends just before the next subnet begins at 8.0. And then that subnet goes from 8.1 to 11.254, ending just before the next subnet of 12, which starts at 12.1. In another example, we're using a Class A address 33.0.0.0 and a custom subnet mask of 255.248.0.0. According to our subnet ID table, the subnet mask of 248 says that the first subnet ID would be at 8. So our first subnet ID is 33.8.0.0. And if our first subnet ID starts at 8, each subnet ID starts at a multiple of 8. So then the next subnet ID is 33.16, the one after that 33.32, and on and on. Now when determining our host addresses, remember it's really quite easy. We take our subnet IDs and essentially add a 1 to it. And that's our first host ID. So on the subnet ID 33.8.0.0, our first host is 33.8.0.1. And likewise down the table. Now the last host ID, remember, ends just before the next subnet ID begins. So our last host ID on our Class A subnetted network at 33.8.0.0, the last host would be 33.15.255.254. And then the next subnet would start at 33.16.0.1, and again end just before the following one began. So the last host address would be 33.31.255.254. The third subnet would start at 33.32.0.1, and on and on. Now that we've determined our subnet IDs and our host IDs, we're ready to go out to our network and start assigning host IDs to the actual computers and network devices on the network. Now we'd go out to the first physical segment. The physical segment, we've assigned the subnet ID of 152.77.32.0 and start assigning host address. Now the first host would be 152.77.32.1. The next one would be 32.2, 32.3, and on. And we'd be able to number all our hosts all the way up to 152.77.63.254. All those physical devices on that same physical segment would then have these IP addresses on the same subnet. And then we'd go to each subnet and assign the appropriate addresses. Also, we'd have to assign the appropriate subnet mask. Now, while every computer on our network will have a unique IP address, they will all share the same subnet mask. In this case, they'll all have the subnet mask, the custom subnet mask we've determined, 255.255.224.0.